Hi, welcome to Dr. Raz, the Baking Chemist. So today's question is a Year 1 inorganic question, so Year 12, but obviously Year 13s or Year 2s will also need it. It's a 6-mark question. It's one of those, another of those challenging questions according to the examiners. Okay, let's see what we can do. You've probably heard about the lockdown, I guess, schools being closed or starting late, 2 weeks late. It's even more important that you try and understand these videos, try and understand these questions, practice these questions yourselves. Okay, just because the school's closed doesn't mean there won't be any exams. Yeah, there might still be exams. No one knows for sure. But even if there are no exams, then your teachers will probably assess you on your sort of monthly assessments or regular assessments. So work hard, please. Just because the school start late does not mean you start relaxing a little bit. Okay, no relaxation, especially if you're in Year 2. You've got to continue, okay, to work hard. All right, and in Year 1, of course, every assessment counts. Yeah, so every test, every assessment counts. So continue to work, please. Okay, so let's get on with it. Okay, so separate unlabeled solid samples. Okay, so solid samples, and they're separate, of 3 anhydrous sodium compounds. Anhydrous sodium compounds are provided for a student to identify. These compounds are known to be sodium carbonate. Okay, so they've told us sodium fluoride, and again, as I'm reading it, I'm thinking about these compounds: sodium carbonate, sodium fluoride. What do I know about this? What do I know about this? And sodium chloride. But it is not known which sample is which. Okay, which sample is which? So I know those immediately. I'm thinking, okay, well, what? Before I even read the rest of the question, I'm thinking, okay, well, what test do I know? Obviously, these are one of those test tube analysis type questions. Okay. Outline a logical sequence. So logical sequence of test tube reactions that the student would carry out to identify each of the compounds. Include the observations the student would expect to make, and give equations including state symbols for any reaction that would take place. So the first thing I'm thinking is there are lots of parts to this question. Okay, and you know what, I'm going to actually just label these parts so I know that I've addressed all of them, and my suggestion is you need somehow to label them as well so you don't miss out. As you'll see in a minute later on at the end, I'll tell you mistakes students made. Yeah, so these okay, so outline them. So there's one, so that's one part I need to do. That's 2. Include the observations students will make, and give equations. That's 3, and state symbols. So that's 4 different things that I've got to answer, and it's worth 6 marks. Okay, so again, going back to this question, so outline a logical sequence. Before I start outlining, and remember, this is one of those levels of response type question. Yeah, now I'm going to do this slightly differently. I've actually printed out the mark scheme, and I'm going to show you the mark scheme. And the reason for that is so you know how the examiners mark these kind of questions. You might already be aware from your GCSE, etc. And if you're Year 2 at the moment watching this, you might be aware from Year 1. However, I think I need to highlight how examiners mark this question so you have an understanding. And so therefore, when it comes to answering this question, you've got that understanding in the back of your head. Okay, so let me just show you. I hope you might be able to see this, but if you can't, then I'll probably see if I can magnify when I'm editing it. Now, so this answer, what the examiners do is they read your entire answer, okay, and then they put it at an appropriate level. So is it level 1, level 2, or level 3? Level 3 being the highest, level 1 being the lowest. And within each level, you get 2 marks. So if it's level 1, so if your whole entire response fits in the level 1, yeah, best fit is level 1, then you'll get maximum 2 marks, okay, minimum 1, maximum 2. If your whole response fits into your level 2, then you get 4 marks or 3, so 3 or 4 marks. And if the whole response fits into your level sort of 3, then you get 5 or 6 marks. Okay, now what they're looking for when they're reading your entire answer, okay, is 2 things. One, that you've addressed all the chemistry, yeah, for the question. So have you addressed everything? Okay, and then the second thing that they'll be looking at is your quality of written response, so your quality of writing. Yeah, does it flow nicely? Have you used sort of chemistry terminology? Okay, does it, does it follow a logical order? And not only that, I mean, even in the question, they've actually told you, outline a logical sequence, right? So they will be looking at that. So within each level, yeah, they'll be looking at your chemistry content and then the flow, the logical sequence. Yeah, if you've got the chemistry content but not the logical sequence, then you'll get the lower of the 2 marks. Okay, so for example here, so they're saying, look, level 1, okay, 1 or 2 marks. In the level 1, have you covered those stages? Yeah, so these stages I'll explain to you later as I'm answering the question. Okay, but have you covered 2 of the 3 stages? There are 3 stages. Yeah, 2 of the 3 stages are covered, but each stage might be incomplete. Yeah, or only 1 stage is covered, but it's complete, yeah, almost complete. And then to get so that'll get you 1 mark. And then to get the second mark within this level is answer includes isolated statements, but these are not presented in a logical order. So for example, if they're not presented in a logical order, you'll get 1 mark, okay? So you've got the chemistry content for 2 stages or 1 stage. However, they're not logically coherent, okay? They're not logically presented, and therefore you'll get the lower of the 2 marks. So chemistry content, okay? The more stages, and as I said before, the stages, I'll explain what they are in a minute, but the more stages you have, the higher level you get. However, within this level, then they're looking at logical presentation, okay? And if it is logically presented, then you'll get the higher of the 2 marks within each level, okay? And if not, then you'll get the lower of each mark, okay? Okay, so let's answer this question, and then I'll explain the stages near the end once I've answered the question, okay? So let's do this. So outline the logical sequence. So how to answer this question? These compounds are known to be sodium carbonate. Now, immediately, don't know whether this is just me or not, but the point is I'm going for carbonate. I'm thinking carbonate reactions. I know how carbonates react, yeah? They react with acids to give you certain salt, carbon dioxide, and water. So I'm thinking, all right, I can simply put sort of acid into this, yeah, into each of the test tubes, or take a sample from each of the test tube and add acid, okay, to it. All right, and if it fizzes, carbon dioxide, if it fizzes, that means it's a carbonate. All right, and that's easy to identify between these 3. Okay, so the first thing I'm going to do is I'm going to add acid. Right, which acid? Well, I can add any acid. All right, I can add any acid, right, to this. Yeah, any acid will react with carbonate and it will show effervescence, and therefore I can immediately say that's a sodium carbonate. Okay, because there is only 1 carbonate. Now, remember, I can put down the fact that, okay, well, I'm going to take a little bit of this powder, each powder, and then put it in a separate test tube and then add the acid to it, and then I can add any acid, not a problem. All right, so I can add acid. So I can add, sulfuric acid, I can add nitric acid, or I can add hydrochloric acid, so any acid. Okay, so you've got to tell them which acid. Okay, so what I can do is I can take each powder separately, right, put it in a separate test tube, and then add any of these acids. If it shows effervescence, fine, it's carbonate. If it doesn't, then it's not carbonate, it could be the other 2. All right, or what I can do is, rather than separating the powders into a separate test tube, I can think ahead. I can think, okay, well, hold on, if I'm going to use an acid, well, I'm looking at this fluoride and the chloride, group 7, right? And you know that group 7 tests are silver nitrate tests, right? So for the silver nitrate, I'm going to have to add silver nitrate to this and this. And I'm thinking, before I add silver nitrate, I have to add nitric acid. Do you remember? Nitric acid is added usually, why? To remove any impurities, yeah? Because they give you false positive. So if I'm going to add nitric acid to these, well, I might as well just add nitric acid to this as well, right? So rather than separating a little bit of powder from each of the test tube, putting it in a separate test tube, I might as well, in the same test tubes. So this is your sodium carbonate, sodium fluoride, and sodium chloride. Now, rather than transferring a little powder into a separate test tube, a little of each of these into a separate test tube, and then adding an acid, right, which will work, and you can do that, you'll get the mark, yeah. I've looked ahead and I thought, well, I'm going to have to add acid to all these 3 anyway, yeah. So why not just add the acid that I'm going to add to these 2, which is nitric acid. So what I'm going to do is I'm going to add nitric acid, and of course, to each of them, and of course, if they fizz, any of them, Don't say carbon dioxide because you don't know if it's carbon dioxide until you've tested it. The only thing is because they've told you it's sodium carbonate, yeah, it's likely to be carbon dioxide. But the observation that you will make, remember, include the observations. The observations you'll see is that this will show bubbles. So I'm going to add nitric acid. So if it bubbles, remember, I'm not writing in logical order yet, yeah? This is my plan. I'm just explaining it in effect, yeah? So if it bubbles, then that means it's going to be sodium carbonate, all right? Okay, now let's say this one bubbles. Remember, I don't know this. This is just me trying to explain it. So let's say this one bubbles, okay? Well, that means this is sodium carbonate, okay? Obviously, these won't fizz, right? Why? Because they won't show any bubbles because yeah, it's halides, right? They don't bubble with acid. But now what I've done is I've added nitric acid to each of these test tubes. And guess what? Now I've identified sodium carbonate, but now I still need to identify sodium fluoride and sodium chloride. But for that, I need to add silver nitrate. But before that, I needed to add nitric acid, which I have done. All right? So these things have already got, have already got nitric acid. Okay, so these have already got nitric acid. So there's this, and that's why I know it bubbled. And this one as well. And now what I'm going to do, so this is going to be no reaction. Okay, and now I'm going to add to both of them what? Silver nitrate. Because I've already added nitric acid, I'm going to add silver nitrate. And now, of course, and this is where your memory work comes in. Yeah, this is where you should have sat down and memorized, well, what is the observation when you add silver nitrate, acidified silver nitrates to sodium fluoride and sodium chloride? Well, sodium fluoride shows no precipitate, okay? But the sodium chloride shows white precipitate. So if one of them shows white precipitate, remember, I don't know which one's which, yeah? So all I've got to say is, if white precipitate, that must be sodium chloride, okay? So whichever of these shows white precipitate is sodium chloride. Okay, now you can draw this. I mean, if you've seen any of my videos, you know I'm a sort of a visual person. Yeah, I like to draw, drawings to see what's going on. Yeah, this is what they call storyboarding as well. I suggest you start using storyboarding if you find it difficult to conceptualize things in your mind. But anyway, so all I've done is I've explained now what the test will be. But remember, if I want to get that higher level 3 with 6 marks, I've got to write it down. Yeah. And present it coherently and logically to be able to get the marks. Okay, so in other words, I've got to make sure I've answered all these 4 parts to it. Okay, I outline a logical sequence of test tube reactions, include observations. So in each case, what I'm now going to do is I'm going to coherently write it down. Okay, and I'm going to write in bullet points, and I think that's not going to be a problem as long as I've answered all the questions. So here we go. So number 1, step 1, or step 1 maybe. Yeah, add nitric acid, yeah, to each test tube. Okay, don't write these abbreviations, write test tube. Okay, add nitric acid to each test tube. Now I've identified the test tube reaction. I've got to now write down the observation for this. So I'm going to say any sample which fizzes is sodium carbonate. Next step. Now, sometimes people don't understand, or students forget, that these are all solids. Now, I have to make all of them liquids before I can add other things. The fact that I've added nitric acid, yeah, aqueous, dilute nitric acid, yeah, dilute. Let's just put dilute. So add dilute nitric acid to each test tube. Let's say, the way I've written it, add dilute nitric acid to each test tube. Let's say I take the first test tube and add dilute nitric acid, and it just so happens that it fizzes. I immediately know that that is your sodium carbonate. Now, if I go to the next step and I say, well, my next step is add, silver nitrate to it, but remember, I've not clarified. These things are still solids. Am I going to just add silver nitrate to the solids, or am I going to, make them solutions first? Right? So I think you can say add dilute nitric acid to each test tube, but I think that's ambiguous. That's not clear. Right, what you're going to do to the other test tubes. Okay, so my suggestion would be add dilute nitric acid to all the test tubes. Okay, any sample which fizzes is sodium carbonate. But now, because you said all the test tubes, that means these are now dissolved. So therefore, they are solutions. right? And so now you don't have to say, oh, make them into solutions or add water to them, etc., etc. Yeah. So if you said add dilute nitric acid to all the test tube, that's fine, but it's got to be all the test tubes. Any sample which fizzes is sodium carbonate. And now, second step is add silver nitrate to the remaining samples. Remember, if you've identified one of them to be sodium carbonate, well, you don't need to do any further tests with that, do you? You know sodium carbonate. So it's only the other two samples that you need to test. Okay, so add silver nitrate to the remaining samples. Okay, and then, so now you can say any sample that shows white precipitate, that's from your memory, yeah, is what? Is sodium chloride. Okay. You've got to say, remember, you've got to write down all the observations, isn't it? So I've not written down the observation for sodium fluoride in this test. Yeah, I've told them what the sodium chloride will be, yeah, white precipitate, but what will happen with sodium fluoride? Okay, so for that, you've got to say sodium fluoride sample will show no visible change, yeah? So no observation or no visible change. All right, so now I've done the observation. So I've done the tests, okay, and I've done the corresponding observations, and I've reached the conclusions as well. So outline logical sequence of test tube reactions. Well, yeah, they are logical. So I've labeled them 1, 2, okay. That the students could carry out to identify each of the compounds. Include the observations. Yep, I've included the observations for that. Okay, that gives me sodium carbonate, and for sodium chloride, and for sodium fluoride. And then it says give equations including state symbols. So my third and fourth part of this answer is give equations. Now equations, again, unless you practice them, you're going to be struggling, okay? But anyway, let's give the equations, right? So let's give the equations for the sodium carbonate, okay? Sodium carbonate, reaction. So sodium carbonate plus nitric acid. Remember, don't make these silly mistakes now, yeah? You've said you're going to add nitric acid. This reaction needs to be with nitric acid, not with, with sulfuric acid or HCl now, yeah? So what you do is remember your basic GCSE chemistry knowledge. Yeah, it's carbonate plus acid equals salt plus water plus carbon dioxide. So let's leave the salt for a second. Yeah, I'll show you why in a minute. So water and carbon dioxide. So it'll be water plus carbon dioxide. Now the salt obviously would be sodium and nitrate because the acid I'm using is nitric acid. So okay, and sodium nitrate. Nitrate has a single minus charge. Sodium has a single positive charge, so that's the formula is correct. If you don't know how to write the formula, ionic formula, learn them, please. Okay, now, is this balanced? I've got a balance there. There's two sodiums here, only one here, so I'm going to have to put 2 here. And that means, there's 2 nitrates now. So there's nitrate group 1, there's only one of them, so I need 2 nitrates. So I'm going to have to put nitrate, and I'm assuming that might balance everything else out. So 2 hydrogens, okay, and oxygens, 3 oxygens, 1 carbon, 1 carbon. Okay, so that is balanced. Have I finished yet? No. Yeah, state symbols, and many of the students missed state symbols. Okay, again, exam situation, rush scenario. Okay, do this and just move on. Right, state symbols. Sodium carbonate is sodium carbonate. Remember, sodium carbonate is aqueous now. And then nitric acid is dilute, so it's aqueous. Now this is ionic, yeah. So this is going to be aqueous. Why? Because remember, these are going to be ions, okay, in solution. Water is a liquid, and carbon dioxide, of course, is a gas. State simple. All right. So that's the sodium carbonate reaction. Now let's show you the other 2 reactions. But the second one, I'll say a bit more about it in a second. So sodium chloride, okay, is sodium chloride plus, and remember this is aqueous, yeah, plus silver nitrate. Okay, remember sodium chloride reacts with silver nitrate, okay, and silver nitrate is of course aqueous as well, and then that reacts, and then that the reason why you get a precipitate is the silver reacts with the group 7 halogen, okay, halogen, so silver chloride, to give you the precipitate. Again, some sitting down and memorizing, yeah, work, unfortunately. And what's left is sodium nitrate again. Sodium nitrate, and what you end up is sodium nitrate is ionic, so therefore it will be aqueous. Okay, again, state symbols are there. And now the final one, now you don't really need a reaction for the sodium fluoride because it doesn't react. Okay, I mean, if you want, you can write down sodium fluoride, no reaction, but I think that's just a waste of time. Yeah, no reaction, because you already put that down here. No visible change, and there was no reaction. Yeah, oh, okay, I suppose you can argue just because there's no visible change, it doesn't mean there's no reaction. But anyway, no reaction, you can write it down if you like, but if you leave it out, that's not a problem. Okay, so look, if this was exam, yeah, I would have, once I did this, this plan, yeah, very rough, very quick plan, okay, I would have then written it out definitely as a minimum like this, and make sure you put steps. Yeah, 1, yeah, add dilute nitric acid. And look how anytime I've written down the observation, I've sort of indented it a bit, so they know any sample which fizzes, sodium chloride. So these are my observations, and then of course add silver nitrate to the remaining sample. That has to be in there, right? That has to be in there. Otherwise, you're gonna have to explain. Yeah, how are you doing this? Which order are you doing this? Yeah, add silver nitrate to the remaining samples. Any sample which shows white precipitate is a sodium chloride. Sodium fluoride which sample will show no visible change. And then of course the reactions. Have I answered all 4 parts? Outline the logical sequence of the tube. Yes, I have. 2, include the observations to your students with correct. Yeah, I've included observation. Number 3, give equations. I have given equations. State symbols. Yes, I've given state symbols as well. Yeah, so please, in a question like this where it's got sort of a multiple parts, yeah, it's very easy to forget. And in fact, in this question, when this came up in the exam, students often forgot the state symbol, so they lost a mark needlessly. Okay, so now knowing this, okay, knowing the answer now, let me show you what the stages were that I spoke about earlier. Okay, and you needed to complete the stages, okay, in order for you to move up those levels. Okay, so let me just show you this now. Here is stage 1. Okay, so stage 1, suggested tests, add named acid to all 3. Yeah, so for example, you should have given a name. You can't just say add acid, right? It's got to be a named acid, the nitric acid. Okay, you can't just add acid to all 3. Yes, and add named acid to all 3. So can you see, add dilute nitric acid to all test tubes. Yeah, add water to make into a solution. Now this one, because I've said to all test tubes, so here you could have said add water to remaining samples. Yeah, so that could have been your 2, and then leading on from that is that. Yeah, so can you see? Yeah, so here, unless you're absolutely clear, because when I looked at that and I realized actually the reason why they said add water is because some students, they could have just put a couple of drops into each tube. So that means not all the test tubes would be solutions. Yeah, and that's why they wanted you to make sure you tell them that you're making them into solutions. Okay, all right, so, and then of course, still part of stage 1, add silver nitrate. So all of this is your stage 1, the chemistry. So you're adding things. Yeah, you're adding things. These are your stage 1. Right, once you've added it, then the second stage is your expected observations. Yeah, so that, in my case, the way I've written it, that is my second stage, these. Yeah, any samples. Okay, and now the point is, it's not a problem. It doesn't have to be, oh, here's my stage 1, here's my stage 2, here's my, no. They just need to follow coherently, and my answer does follow coherently. So I've added something and I've told them about the observation, then I'll add the next thing and I've told them about the observations. Okay, so it's not a problem. Yeah, so anyway, so stage 2 is expected observations and conclusions. So sodium carbonate will fizz with acid, right? Any sample which fizzes is sodium carbonate. So I'll put that. Sodium chloride gives white precipitate with silver nitrate. So because I've said silver nitrate, and then any sample that shows white precipitate sodium chloride, so that's your stage 2. And then your still part of stage 2 is sodium fluoride. Yeah, shows no visible change or no precipitate. Okay, so that is still part of stage 2. So at stage 2, what you've done is you've actually told them what your observations are. And then of course stage 3 would be the actual reactions, okay, with state symbols. All right, and in order to get to the top level, yeah, to this level here, okay, level 3, you need to have all 3 stages. So addition of chemicals, observations, and reactions, including state symbols, but have them written in coherent and logical manner to get to this level 3. And of course, that'll give you the higher of the 2 marks in level 3. All right. Yeah, I mean, they are, putting these kind of questions quite a lot as well. Actually, in every exam, you will get these kind of questions. what they call levels of response type questions. Okay, and here what I would suggest is 6 marks. So maybe spend a minute maybe on planning. Yeah, what you'll do, just rough, and do it in the exam paper. Yeah, rough planning. Okay, the reason I'm saying is do it in the exam paper is that just in case you don't have time to finish this, right, then at least they got your rough plan, and they could give you, okay, at least you got the chemistry there. It's not logically presented, but it'll still get you marks. All right, so plan it, spend a minute or so planning it, and then write it coherently. Okay, it could be in bullet points. Yeah, it doesn't have to be full paragraphs. Okay, like I did. As long as it's coherent, it follows a logical structure, shouldn't have a problem. And of course, you answer all the questions, all the parts. Okay, so this is a sort of test tube reactions type question for group 7 on carbonates, of course, but test tube reactions. For this type of question, I wish I could say there's an easy way to sort of come up with the answer if you've not sat down and memorized it, but unfortunately, you're going to have to sit down and memorize it. Memorize the observations, yeah. The reaction equations you can think about, I guess, and come up with it like I did, but it's better if you do know what you get. So general equations, salt plus water and plus carbon dioxide and so on. This is where the students sometimes make mistakes. Now, other places where students have made mistakes is, okay, they have started the question assuming, like I showed you here, but remember I showed you here just so you know what the observations would be, right? But you can't assume that this test tube is sodium carbonate, this test tube is sodium fluoride. You can't start from already knowing which test tube is which. It's got to be as if it's an unknown. I'm going to add this. Yeah, you can't say I'm going to add nitric acid to the sodium carbonate powder sample. Well, you don't know which one is sodium carbonate, so you can't start things like that. So be aware, yeah. I mean, the silver nitrate tests are well remembered according to the examiners. Okay, so that wasn't a problem. I think the order, some students got it wrong. In fact, quite a few students got the order wrong. So what they did was they'd add acidified silver nitrate to all of them, and then of course, if this was your only sample, you have none left to test for carbonates. Yeah, so they started with silver nitrate, acidified silver nitrate, which is a problem because once you've used that up, there's no sample left to test for carbonate. So that's the order is important. Okay, well, I hope that was useful. If you think I can explain it better, how to do this question, or if you do this question slightly differently, maybe use a sort of a table, table of what you already know and what you need, and etc. etc. I don't know. There might be some different ways of doing it, but if there are, let me know in the comments below. If you're not subscribed, please subscribe and share this, please, with your year 1 colleagues as well. If you're not year 1, if you're year 2 students watching this, share it with your year 1 as well. These videos. Okay, well, thank you very much. Don't forget, like the video, please. Yeah, a lot of people are watching it, but they're not liking it. Like the video, please. Okay, I'll see you next Wednesday. Bye.